Question number 6. So a ball of mass 0.4 kg mass is given, is attached to a string of length 0.8 meters. Okay, the ball is rotated in a vertical circle such that the speed at the lowest position is 6 meters per second. So what does it say? This speed is 6 meters per second. Okay, the mass is also given 0.4 kg. Now what is the tension of the string when the ball is at its lowest position? So what we need to do? So it is something related to force here, right? So therefore tension is acting here, then mg is acting here, right? So let us draw the free body diagram. What is the free body diagram tell you? It tells you P minus mg is equal to mv square by r. Why do we use this? Because in a circular motion, the right hand side should always be mv square by r. The left hand side would be the driving force, right? So driving force is tension. You are pulling the string every time, right? So therefore tension, but at the same time mg is acting downwards also. So both of them will act simultaneously. So thus you get this expression. What I will do is d is equal to m into g plus v square divided by r. Now let me write down the values. This is 0.4, 10 plus v square. What is v square? V square is 36 divided by r, which is 0.8, which should now be equal to, let's take this calculator, it should be 36 divided by 0.8 is equal to, oh, I made a mistake here. 36 divided by 0.8 would be 45. So this should be 0.4 into 10 plus 45, which should be 0.4 multiplied by 55. 4 by 10 into 55. By 2s are, by 11s are, 2 1s are, 2 2s are 22 Newton. So the answer is 22 Newton. Okay.